Let's quickly review what a rotation is before we get into some more examples. Before we start actually physically rotating, we're going to frequently be asked clockwise or counterclockwise. And I always tell you, look at a clock where the 12 is at the top of the clock, and a clock rotates this direction normally. So that makes this direction clockwise. And if we go the opposite direction of that, we call that counterclockwise. So I think it's always easiest to think about the top of a clock and you're rotating to the right or to the left. The most important thing to remember when we're talking about rotations is that if this is the center of our rotation, every single point that is being rotated about the center needs to be the same distance away from the point of rotation. Now, obviously, the direction is going to be different, but if our problem is done correctly, you all need to be the same distance away from the center when you're done. Then, we're frequently going to be thinking about number of turns. A full circle is 360 degrees, so that makes each individual turn 90 degrees separate. So 1 turn is 90, 2 turns is 180, 3 turns is 270, 4 turns is 360, getting you back to where you started. Now, once again, I talked about in the last video to physically rotate a sheet of paper if you can, okay? The best thing you can do is to physically rotate that paper as you solve these problems. But we don't have that, so we got to use some different strategies. The strategy that I use first is I make sure I figure out what we're rotating around and how far we're rotating. So we're doing 180 degrees around the origin. Now, if I'm rotating around the origin, okay, that means I can rotate either clockwise or counterclockwise because 180 degrees is halfway both directions. So that part does not matter. Now, I look at the point that is closest to our rotation. So one rotation puts it here, keeping it close to this line, which is the x-axis. So if I rotate it again, it goes down here, and it needs to be close to the y-axis. Okay, so that means it needs to be 1 unit away from the y-axis, and then it's going to be 1, 2, 3, 4 units away from the x-axis. So that makes our x prime coordinate right here. I will tell you a lot of people, if they mess this up, will rotate it down here. And the reason why that doesn't work is because we need to be 1 unit away from the y-axis in our rotation. So if you physically rotate that paper, it's definitely easier to see. Now, our x coordinate goes down here. That means our z coordinate has to rotate all the way down and be flat in this direction away from our x coordinate. So 1, 2, 3 units away. 1, 2, 3 units away in this direction is our z prime coordinate. Now, y has to be between our x and our z, but it is closer to x than it's closer to z than it is to x. So it's down 1, 2, 3, 1, 2, 3, and it has to be closer to z than x, so that makes this our y prime. From here, I can just connect our points. And a lot of times you can tell with an eye test if you've done that rotation correctly. Usually your eye can register if something doesn't look right. But this one, if I physically rotate the triangle down, this would be correct. So let's do one more example here. We have polygon ABCDE, which is this crazy monstrosity down here. And we're going to rotate it 270 degrees counterclockwise around the origin. So counterclockwise is this direction. So I'm going to go 1, 2, 3, and it's going to end up down here to our left. But if I rotate something 270 degrees counterclockwise, that's the same as doing 90 degrees clockwise, which means that I'm actually going to be going 90 degrees this way. Will be the same thing. So you can think about it in either method. But if we're thinking about it as 90 degrees clockwise, I think of point A right here. And point A is closest to the y-axis here. So when it rotates, it needs to be closest to the x-axis here. So it needs to be 1 unit away from the x-axis, and then it's going to be 2 units away from the opposite axis, which means A prime ends up right there. From here, E is going to rotate all the way up, so it's going to be over here somewhere. So 1, 2, 3, 4 units away. So our E prime is right here. From here, B is in the opposite direction of E. So that means B has to be down here as B prime. Now here's where it gets a little bit tougher. Okay, so B is closer to A than C is. So it means that our C has to be 2 units away in this direction and 1 unit away in this direction. So here is our C. And then our D is going to be 2 units flat away from C, but towards E. So it's not going to go this way. It's going to go back up to here. And there is our D prime. Now we got all the points graphed, and we need to connect them. And there is our new rotation. So a little ugly, but it works out. You just got to go 1 point at a time. So now we're going to do the same thing in the opposite direction. So 270 degrees counter or regular clockwise is 1, 2, 3 turns this way, ending us up over here. But 270 clockwise is the same as 90 degrees counter clockwise, which means that if we just think about 1 turn, counterclockwise will be up here. Okay, so now A is still the closest point, and it is 1 unit away from the y-axis, so it needs to be 1 unit away from the x-axis, so up here. So that means it's going to be over 2 and up 1, and there is our A prime. We're going to do this in a different color here, so we'll do A prime right there. Okay, so now B is over this way normally in the pre-image, so it's going to be up 2 this time, so B prime is right there. E is in the opposite direction of B from A, so I'm going to go 1, 2, 3, 4 to get our E prime over here. So then our C is an extra unit away from A in this direction, so that means C is going to be here. Did I do that one right? Yep. And then D, I must have made a mistake with our C here. So C is going to be, there we go, it's going to be right up here. And the reason why I can tell is the shape changed. If I put my C up here, it changes the shape a little bit, which is actually not the goal of any rotation. If the shape changes, it's no longer congruent to the pre-image. And there we go. That does look correct now, this is as tough as rotations can be. If you're able to do this type of rotation, you're able to do all rotations in this section. But as always, if you have any questions, please let me know.